Now we are moving to the one final application or a method to find out some important parameters about the signals. So I hope you have somewhere heard this word Lissajous figures. When I was studying wave and mechanics in my undergraduate courses, at that time, very first time I came to know about this. This is a kind of pattern formed due to standing waves, and so if we don't know what is Lissajous figure, still we will be able to understand. I have tried to write significant information applied. It says Lissajous figures can be displaced by applying two AC signals simultaneously to the X plates and Y plate of the oscilloscope. So we know X plates are for horizontal move and Y plates are for vertical moves. So if you remember the block diagram, you have seen there are two pair of plates on in CRT which can reflect electron beam horizontally and vertically. So how we can get Lissajous figure? It says if we apply two AC signals simultaneously on X plate and Y plate. If we do this, so at the frequency, amplitude and phase difference are altered. Different patterns are seen on the screen. So if we give two AC signals, so there will be something on the screen because CRO is a display device. So it says if we change frequency or amplitude or phase difference, so the pattern, what we see on the screen, different kind of pattern we see on the screen. So Lissajous figures are obtained when the oscilloscope, when this is operated in XY mode, when in both channel 1 and 2 voltages are applied. So it said these figures, if you don't know what are these figures, we are trying to explain what it is. Lissajous फिगर मिलते कब है जब हम दो एसी सिग्नल एक्स वाई प्लेट पे लगाते हैं और अगर हम उन सिग्नल का फ्रीक्वेंसी एम्पलीट्यूड फेज डिफरेंस चेंज करेंगे तो जो पैटर्न बनते हैं स्क्रीन पे वो चेंज होते रहते हैं और लिसोजस फिगर तब मिलते हैं जब हम सीआरओ को एक्स वाई मोड में ऑपरेट करते हैं और दोनों चैनल 1 चैनल 2 पे वोल्टेज अप्लाई होते हैं। अब कुछ कंडीशन है जो लिसोजस फिगर्स होते हैं। इन नेक्स्ट स्लाइड वी विल सी द पिक्चर व्हाट आर हाउ डज इट लुक्स लाइक। So there is a very important point, this fourth point, where we are defining what are Lissajous figures. So it said if the ratio of the two frequencies of the voltages, जो दो voltage हम लगाए हैं, उनकी जो frequency है उनका ratio, if it is equal to a rational number, then standing figures appears on oscilloscope. Standing figure means if you remember standing wave. So loops kind of a structure. So it appears on the oscilloscope, and that structure is called Lissajous figure. And if frequency ratio is not a rational number, मतलब अगर दोनों frequency का ratio ले हम और वो rational number ना आए, तो क्या होगा? जो figure दिखेगा, that will keep on moving, and it will not be in a standing figure. So that we can't say that it is Lissajous figure. तो Lissajous फिगर बनाने का कंडीशन क्या है? हम लोग दो सिग्नल दे रहे हैं और दोनों को जो फ्रीक्वेंसी है उसका एक रेशियो रेशनल नंबर होना चाहिए. So this is one thing. So it is a very crucial point when we define what are Lissajous figure. So in this way it is possible to make a small frequency difference. Now it is telling why we use this and how it is important and what we can measure using this. So it said if there is very small frequency difference between two signals, like if it is 2 times, 1 time, 3 times, means this is like a rational number. The ratio we are talking about, the ratio of two frequencies should be a rational number. So it says if there is slight difference, थोड़ा भी अगर difference होगा तो वो हम उसको देख पाएंगे. वहाँ पे standing wave, standing figure नहीं बनेगा, Lissajous figure नहीं बनेगा, and then we can measure it. Okay. So this is one thing. and unknown frequencies can be determined. So there are two waves, two signals, two AC signals we give, and we know frequency of one signal, we don't know others. Then also we can measure unknown frequency by looking at the Lissajous figure. जो दूसरा सिग्नल है जिसका फ्रीक्वेंसी हमको पता नहीं है वो कितना है, that can be measured. This is an application. So unknown frequencies can be determined if these are applied to one channel of the oscilloscope and are superimposed with voltage of known but adjustable frequency from a function generator applied to the channel. मतलब कैसे करेंगे ये उसको बता रहा है कि अगर हम एक चैनल पे अप्लाई करें और अननोन फ्रीक्वेंसी का जो है वो नोन पे सुपर इम्पोज होगा और जो लिसाजस फिगर बनाएगा उस लिसाजस फिगर से हम दूसरे सिग्नल का फ्रीक्वेंसी कैलकुलेट कर सकते हैं. So what is the use of Lissajous figure? We understand Lissajous figure and then we are trying to understand what is the use of Lissajous figure. So use of Lissajous patterns to calculate phase shift. जैसे हम लोगों ने अभी एक बार देखा कि हम phase shift कैसे calculate करते हैं, पहले सीख रहे थे बिना Lissajous figure से. तो ये there was a formula. This was the formula and there are two waves and then we know what is the phase shift in centimeter and then period in centimeter and then we change put this formula and we are able to get this. And then how we are doing the same thing phase shift by using CRO. So this Lissajous pattern. So Lissajous patterns are obtained on this oscilloscope simultaneously by applying two sinusoidal inputs to be compared at the vertical and horizontal channels. So we have already said this, but it is more clarifying कि अगर हम दो sinusoidal waves, sinusoidal inputs दिए तो Lissajous figure हमको इसके ऊपर मिलेंगे और इनको हम लोग यहाँ पे vertical and horizontal channel पे कंपेयर कर सकते हैं. The phase shift is then determined using measured value taken from resulting Lissajous pattern. जो Lissajous pattern बनेगा उससे हम लोग phase shift determine कर सकते हैं. We will go through Lissajous figure कैसे करते हैं ये सब हम लोग करने वाले हैं, कोई परेशान होने वाला बात नहीं, but we are just getting to the details. So this pattern on the CRT screen may be either a straight line or a circle or an ellipse depending upon the amount of phase shift. तो ये बता रहा है कि जो phase shift Lissajous pattern से दिखता है उसमें हम लोग CRT screen पे स्ट्रेट लाइन, सर्किल या एलिप्स जो भी होगा वो देख पाएंगे डिपेंडिंग अपॉन उन दोनों में फेज शिफ्ट कितना. अब देखो ये Lissajous फिगर होते कैसे. These are the Lissajous figure. This is the kind of structure we will be looking at screen when we apply two AC signals on horizontal plates and vertical plates. So what kind of pictures we will see on the screen, and these patterns are called Lissajous figures. So you see, we see this kind of, this is a circle on the screen. And what does it mean? It means that those signals, दोनों सिग्नल का frequency बराबर है. Fy is equal to Fx means the ratio is 1. If you take ratio of frequencies of both signals, it is 1. So we will have this kind of pattern on the screen. If it is 2 times, Fy is 2 times Fx. Fy means frequency of AC signal which is applied on Y plate. This is frequency of a signal which is applied on X plate. So it is 2 times, then we will have this kind of pattern. So there are 2 loops. Okay. And it is 3 times, then we have 3 loops. It is half time is Fy. Vertical plate is Fx is equal, Fy is equal to 1 by 2 Fx, or we can say Fx is equal to 2 times Fy. So जो Fx का frequency मतलब frequency on of signal applied on X plate is 2 times the frequency applied upon Y axis, Y plate. Then we have 2 loops, but these loops are vertical. and it is 1 by 3, 3 by 2, 2 by 3. There are a lot of combinations has been shown, and this kind of patterns are called Lissajous figure. So the condition is amplitude is same and frequency different. There are two signals applied on X plate and Y plate, and their frequency is different, but their amplitude is same. So for this situation, we will have this kind of patterns. So as of now, what we know, Lissajous figure क्या होते हैं, Lissajous figure हम कैसे हमको मिलते हैं और किस तरह से दिखते हैं अगर फ्रीक्वेंसी और उनका कंडीशन जो ये बताया कि फ्रीक्वेंसी का रेशनल नंबर होना चाहिए. तो अगर ये रेशनल नंबर नहीं होगा रेशियो, तो क्या होगा, वो मूव करता रहेगा एक स्टैटिक तरह का लूप स्ट्रक्चर, स्टैटिक दिखेगा नहीं. तो इससे हम लोग वो फेज शिफ्ट के बारे में फेज शिफ्ट निकाल सकते हैं, नॉन फ्रीक्वेंसी निकाल सकते हैं. दिस इज एप्लीकेशन व्हेन वी डू वाई वी अप्लाई एन एक्स. दोनों प्लेट पे हम सिग्नल अप्लाई करके क्या करना चाहते हैं, उसका मतलब ये है कि लिसाजस फिगर हम लोग जान गए और वो कैसे दिखते हैं ये हम जान गए, उसका दिखने का कंडीशन क्या है ये हम जान गए. नाउ वी आर talking about how we use it. So we have discussed that we can measure unknown frequency and phase shift using this kind of this is an application where we can measure unknown frequency using a known frequency and a phase shift. So how we do that? We are going to the next slides to understand that feature. But I hope you have clarity in understanding the Lissajous figures and how they are obtained on CRO screen. So the unknown frequency can be accurately determined with the help of CRO. The steps of the procedure are as under. क्या करेंगे? एक known frequency. A known frequency is applied to horizontal input and known frequency is applied to vertical input. दो इनपुट है जिसमें अप्लाई. The various controls are adjusted. मतलब क्या कि जब हम लोग CRO करते हैं, कुछ भी सिग्नल देते हैं, तो उसको हमको डिफरेंट नॉब से ऐसे एडजस्ट करना होता है कि स्क्रीन पे प्रॉपर्ली सिग्नल दिखे. If you don't do the tuning, maybe you are not able to see the proper shape of signal. So for that we have to change it on up and down. You have to change its frequency, means time knob, time based knob, and position on x-axis and y-axis. All this we can do using knobs. So using this figure technique. So हमने क्या किया, दो सिग्नल लिए, एक नॉन फ्रीक्वेंसी का, एक अननोन फ्रीक्वेंसी का. नॉन वाले को हॉरिजॉन्टल इनपुट पे अप्लाई किया, अननोन वाले को वर्टिकल इनपुट पे अप्लाई किया और कंट्रोल एडजस्ट किए गए एंड वी गॉट अ पैटर्न. So if this is the pattern, then how we can tell the frequency of known signal. So if you remember what we were showing in previous slide, these are different patterns. और हमको एक frequency पता है, तो दूसरा frequency calculate करना is nothing. It's very simple. So that is what we are doing here. So there is a method, there is a formula for that. So the number of loops cut by the horizontal line. तो हम क्या करेंगे, एक हॉरिजॉन्टल लाइन खींचेंगे, जो लूप जो भी जैसे कोई भी स्ट्रक्चर बन गया, so let us trace it on a tracing paper and then write and draw an horizontal line, draw a vertical line, and then you check how many loops it cut. So like if we look on this, so this line cuts only one loop, and this line, this is vertical line, it cuts two loops. This one, this is one. It goes like this, one loop, two. So this is the thing we have to look at. Okay, so just still 10 minutes. Let's continue. So we measure the number of loops cut by horizontal line, and we measure the number of loops cut by vertical line, and we put in this formula FV by FH. FV means frequency of signal applied on vertical input, and FH means frequency of signal applied on horizontal input. is equal to number of loops cut by horizontal line, number of loops cut by vertical line. So you need to know this formula. वर्टिकल यहाँ पे है, हॉरिजॉन्टल यहाँ पे है, और इधर ये उल्टा हो गया, इधर ये हॉरिजॉन्टल है, इधर ये वर्टिकल. So this formula is important. Do a problem where this has 3 parts. So what we do, we need to determine unknown frequency using here we have let us read the question. It becomes more clear. When signals of different frequencies were applied to the vertical input terminal of oscilloscope, the patterns are shown for obtained. If the frequency applied to horizontal plate, so ये एग्जाम्पल क्या कहता है कि हमने 2 डिफरेंट फ्रीक्वेंसी अप्लाई किया और उसमें एक फ्रीक्वेंसी हमको पता था. ये बोल रहा है कि जो हॉरिजॉन्टल प्लेट पे अप्लाई किया वो फ्रीक्वेंसी, उसका फ्रीक्वेंसी 1000 हर्ट्ज. अब ये चीज याद रखने वाला है कि ये जो लिसाजस फिगर बन रहे हैं उसमें जो सिग्नल है उनका एम्पलीट्यूड बराबर है, एम्पलीट्यूड चेंज नहीं है, उनको फ्रीक्वेंसी में डिफरेंस है. फ्रीक्वेंसीज आर डिफरेंट बट एम्पलीट्यूड इज सेम. तो क्या किया, एक पर हम लोग एक अननोन फ्रीक्वेंसी लगा रहे हैं, मींस ऑन वर्टिकल इनपुट टर्मिनल वी आर अप्लाइंग एन अननोन फ्रीक्वेंसी एंड ऑन हॉरिजॉन्टल इनपुट टर्मिनल वी आर अप्लाइंग ए नोन फ्रीक्वेंसी दैट इज 1000. तो हमने क्या किया, 3 डिफरेंट फ्रीक्वेंसी अप्लाई किया और हमको ये 3 तरह के फिगर मिले. अब हमसे पूछा जा रहा है कि जो अननोन फ्रीक्वेंसी है तीनों के केस में वो क्या क्या है, उसको कैसे बताएं. तो यहाँ पे हम लोगों ने देखा था कैसे करते थे. दिस वाज द फॉर्मूला FV by FH. हमको हॉरिजॉन्टल प्लेट पे कितना दिया है हमको पहले से पता है, 1000 हर्ट्ज. FV we don't know. So for all 3 figures we have to apply this formula and get to the result. So what we do, let's go to the first question. This is the first question where you see draw an horizontal line, draw a vertical line, and then we do how many loops it is crossing. It is crossing 1 loop, crossing 1 loop. So today FV by FH is 1 by 1, and so FV is equal to FH, and FH is already been 1000 hertz. So we came to know if we get this pattern, it means we have applied a signal on vertical plates. Vertical inputs is 1000 hertz. Similarly, this is for another. If you go for this figure, if it's here, you see this is on this side. If you go the draw the line, it will be 2. It will be 1. So here you see 2 by 1, and this is 2000. So frequency of unknown signal is 2000 in this case. And if you go on this case, here you see 1, 2, 3, 4, 5, 6. So here 6, and this is 1, 6 by 1, this is 6000. So this is so simple. If you know the formula, if you know the Lissajous figure, and you know the technique how to evaluate. So if I give you any Lissajous figure, if I tell you a known frequency, then you will be able to tell unknown frequency. So you need 2 things. One is Lissajous figure. One is one known frequency. So this is how we can do. This is like a practice problem.